this video, we're going to try to make car engine sounds for a Unity game, a driving game, like a car like this. Okay, so say for example here I have this car and I'm going to drive it and I need to have the sounds of a car. So there, the engine is idling. And we have sounds like crashing, car starting, gear shifting, ambient car noise like the wind. Just trying to make it feel the realistic sounds of a car driving, trying to get it as real as possible, right? So the main sound is that engine revving. That's the main sound that we have to find. So what I'm going to first do is think to myself, where can I get some sounds? So I kind of would go to YouTube here, and I just typed in car sound effects, and then I could kind of come up with results here. So let's see, ultimate supercar sounds, 15 minutes of it. So the thing to try to remember for the car engine sounds is I want to try to get a sound of a car with a consistent engine revving instead of accelerating. So let's see, some of these are really long. Let's say that this one here, this video, has sounds that I like. Now, how am I going to get the sounds out of this video onto my computer so I can use them in my game? All I'm going to do is I'm going to copy the video URL by right-clicking on the YouTube video and say copy video URL. And then I'm going to go to a site called mp3download.to. And then here, I could convert a YouTube to an MP3. And it's a free thing. So I put it in here, paste, and search. I could pick the quality, so I'll download that. And I can't do that. Okay. What? Oh, it's because the video's too big. So let me just try to find a different video. How big is this one? 13 minutes. Start the sound. Okay, that's good because that has like that revving thing right here. Paste and just search. And now this one is 13 minutes. So if I say download, and it says, okay, the file is being prepared for downloading. And then we get this button, and I'm just going to download it now to my computer. I'll put it on my desktop. So it finished downloading. So now let's take a look at this. There's this other program I downloaded, Audacity, and that is also free, and I could use that to play around with this MP3. And this is the So what I'm going to do is I have to find a spot in this long thing that has something consistent for an engine rev that's not accelerating. And what I think is like right here in this section here, I just I'm using the select tool and I just drag my mouse to select this piece of the MP3, and let me just press Shift Spacebar to play it in a loop. Okay, so that part, I just want to cut it out. So let me do an edit, copy, and then file new. And in this new one, I'll paste what I just cut. Now it's just that smaller piece of sound. I can take off the extras. And somewhere in here, there's going to be the constant RPM thing. So I press play. Okay. Right here. Okay, so right here, if I just select a piece of it, I think this is like a nice, and let me press Shift Spacebar to hear it loop. Okay, so there, let's edit, copy, and let me close that original one that's taking up a lot of memory. All right, we got this one. Now let me just do another new for just that piece. Edit, paste. Now I have this one piece here. And it's going to have a little bit of problems looping. It doesn't sound that good yet. So what I'm going to do is I'm going to I press Control A to select everything, edit, copy, then I go to the end of the sound. I press this here to go to end of the sound, edit, paste. Okay, now this is the same thing pasted, but now what I'm going to do is I'm going to reverse this part, effect, reverse. All right, and now if I shift spacebar, it's a more consistent sound. See, it sounds even, and it can go on forever. This is going to be the sound of my engine that I'm going to use. So I'm going to say File, Export as an MP3, and I will put this on my desktop here, and I guess I'll call it Car Engine 02. Save. So that'll be my engine revving sound. And I go back to this part here because over here I did have the sound of a car starting. So let's see how much of that I want to take, and I'll make that my car start sound. Go back to the beginning, press play. So it would be like this part for the car start sound. Edit, copy. Well, I could just select that part, select the part that I want to be the car start sound. Let me just test it. Or I could select it up to where the engine revs. Okay. Now I could say File, Export, Selected Audio, and this could be my car start 02 sound. Save. All right, so I have two sounds so far. Let me close the Audacity. The car engine and the car start, just for some more effects that I'm going to have later on the same car. And this was my main source file that I extracted the audio from a YouTube video. So I have these two files. Let me just organize a little bit. Engine and start. Now what I'll do is I'll start another Unity project. So I'll open my Unity hub and I'll make a new project. I'll call it Car Engine Sound 2. It's going to go there, say create. Okay, we got a new project. Now I just need to get something in there. I need to get a track. I made a track in Blender, and you could see this track and how to make one in another video I have. So I'm going to drag and drop my track FBX. The track FBX, if I drag it over here, the materials aren't there yet. Let me drag in the texture for my track, and there you go. Now it has the FBX with the material. Now we have a nice racetrack that I made in Blender. Now we just need a car to go on the track, and I also have that. Let's see. Here's a car. I'm dragging that FBX in, and this FBX I made in Magica Voxel, so I need the texture for it, and that would be this right here. That's the texture, and I'm gonna have to make a material out of that. So let me just put in a cube. It's a kind of a fast way for me to make material here, and I'll drag this onto the cube, which there, I made a material. Now I can get rid of the cube, delete, and let me put the car, whoops. Let's take the car right here and then have it use this material that was made and say apply, and there you go. Now the car is textured too. So the track, just organize. The track is going to be a static object, of course. It doesn't move. Yes. And then all these child objects, these are the parts of the track, like the barriers, the side of the track, I call it the gravel on the left and the right, and then the road in the middle, left and right side of the road. The reason I break the track up into pieces is so when the car is driving on the track, I could tell what it hits, if it hits the barrier or not. So anyway, I select all these parts of the track, and then here in Add Component, I'll just add Mesh Collider. Okay, now they all have a collider. Then I'll take the car and I'll pop it on the track. Boom. So let me see if I like the size of the car to the track. The car is a little bit bigger, so let me just make the track and scale it up a little. All right, and then take the car and just reposition it again on the track. Just setting up my scene here. Okay, it's floating in the air a little bit. Now the car, it also needs a mesh collider. So I'm going to add a component, physics, mesh collider. And this mesh collider will be convex. And I also need a rigid body, physics, rigid body. And I'm going to set the drag to 1 and the angular drag to 5. I'm going to say for interpolate to extrapolate, and for collision detection to continuous dynamic. That way when it slides around the track in the best way I like with those settings. I'm going to use physics to move the car. I'm not going to use the wheel colliders. Okay. Now I'm going to need a script to control the car, to control the car's movement around the track. So let's start to write a script. And over here, let me just organize things a little bit better. Let me make a folder for my textures, and I'll put them in there, texture folder. Whoopsie, what happened? Why did my road just lose its stuff? Is it because it's not in the same folder? Oh, that's interesting. Let's see, this track, the material is none. Let's do the same thing I did with the car for the material for the track. Okay, so I'll just stick a cube in there again. I got rid of it too soon. And let's see where the cube is, and drag and drop that on there. Now it should have the material in the material folder. Yep, there it is, race game material. Now I should be able to take this and drag it in here. Okay, it did lose the material, but now here I could say use race game material, bam, and apply. There we go. Things are coming along. Let's take a look at our car. I need a script for the car, so right click, create a C# script, and we'll call it car. And we're going to open up Visual Studio, Microsoft Visual Studio, to start coding the script. Okay, let me just cut this out, and let me start off with some variables that I know I'm going to need to move the car with. So first I'm just going to kind of do a little car movement control here. Move speed, and I'll say that's 50, and public float turn speed equal 60. I need a pointer to rigid body. Private rigid body RB equals null. Then in the start function, private void start, I'll set the rigid body equal to this dot get component rigid body. And then we're going to have the car movement controls. So I'm moving by using physics in the rigid body. So I'll have a private void. I'll use fixed update, since fixed update happens every physics update instead of update, which happens every frame update. I'm using physics to move the car, so I'll use fixed update. All right. And in fixed update, I will get the float move equal to the input.getAxis vertical. So that's the input manager. There's a definition for vertical, and that's basically the keys for vertical are, what are they? W, S, or the up and down arrows. Okay. Then float for turn will equal the input.getAxis horizontal, and that is the A and D, or the left and the right arrows. The values that come back from these get axis, they basically go from -1 to 0 to 1. Okay? And they're float values, so that means it's all the values in between. They kind of, if you hold down the key, the value, like if I hold down W, then it goes to -1 kind of quickly, and that's all in the input manager of Unity. So we have that. So now for move is going to be vertical, right? That's WS, that's up and down. So move, let's see what we'll do. If move equals 0, okay, if move is less than 0, then we're moving the car backwards. So we're going to apply a force, a relative force, to the car to go backward. RB dot add relative force. And do I have to explain relative force? It's because the car, these are the axes of the scene. See how Z is pointing forward there? Those are the axes of the scene. But the car has its own forward. If I take a look at the car, you see that's the forward of the car. But if the car turns, now its forward is this way, even though the scene's forward is this way. So when I want to apply the rigid body force, I want to apply it to the car's forward. So that's why I use add relative force relative to the car. All right. So let's see, this is going to go backward, right? So vector 3 dot back, that's the direction. And I'll say the move speed times time dot delta time. And the kind of force to apply will be force mode dot velocity change. And you can see here in the pop-up it says it adds an instant velocity change to the rigid body, ignoring its mass. Okay, so it doesn't matter how heavy it is, it's just going to add this force to go backwards. All right, now else if move is greater than 0, then I'll take that as to move forward. So rb.add relative force vector 3 dot forward times move speed times time dot delta time, and same thing, force mode dot velocity change. So now my car should be able to move forward and backward. Now let's take the turn value, the horizontal buttons, and let's turn the car to the left or to the right. So for turning, if turn is less than 0, then I'll be turning left, right? So I have a little bit more complex formula for the turning so that the turning is smoother. So just follow me here. Vector 3, rotate 2. Then in here, I'll set the rotate 2, a new vector 3, this dot transform dot Euler angles x, comma, this dot transform dot Euler angles dot y minus 45, comma, this dot transform dot Euler angles dot z. So XYZ axis angles. But the thing is that I'm moving a little bit. And should I move 45 degrees each time? Maybe I should move like 20 degrees each time. And now I say this dot transform dot rotation is going to equal quaternion dot rotate towards. So from this dot transform dot rotation, turn to quaternion dot Euler rotate 2. How fast do I turn to that? Turn speed times time dot delta time. Okay. Ooh. Yeah, I kind of changed my formula for the turning of the car a little bit to have it be a little bit smoother instead of jerky. So that's how, with this rotate toward, I could control the turning looks a little bit smoother instead of popping that too much. So if turn is negative, I turn to the left. Else if turn is positive, else if, let's see, I'm going to copy almost all the same stuff here, and I'll just change a couple of things. So let me copy that and paste it. One, instead of going to the left, I'll go to the right with a plus 20. And then the turn speed, this transformer, yeah, that's the same. Okay, so that's there. Then I think that's that. So now I could move the car and turn the car. Let's go ahead and put the script on the car. I could delete this cube that I used to make a texture. So here's the car, and I'll drag and drop the script on there. And if we press play, let's just get a view where I could actually see everything. Main camera, Control Shift F. Then I will press play, and I will try to move the car with the keys. So we're in play mode. I can turn left and I can turn right and I can move forward. Okay, so it's working, the movement. And as the car goes around the track, I probably would like to be able to see the car as it goes around the track. So let's make a script for the camera to follow the car. So first thing on the car, let's give it a little target for the camera to move to. So I'm going to select the car. I'm going to right click and add a empty game object. I'll call it move to. And this is going to, oops, I said moved to. Move to. Okay. And that's not a visible object in the scene, but I could give it a visible color with these select icons. So I'll make it purple. And now you can see, let me select it. And now you can see I got a little purple dot. And let me just make the 3 icons like that, small. All right, so wherever this dot is, that's going to be, I'm going to make a script that the camera is going to try to follow that dot along the track so that the camera's kind of like behind the car and it tries to follow it. Okay, so let's put that dot there and save it. All right, so now for the camera, we need to make a script. So let's call this script cam follow, because that's what it's going to do. And let's write the script. Let's double click on it and open it in Visual Studio. Let's gut it out and start off with the variables. We need public game object move to equals null. Then we need public game object look at equals null. So I'm going to tell it I'm going to tell the camera where to move to, and I'm going to tell the camera where to look. Public float move speed of the camera will be a 4, and public float look speed of the camera, let's say 320. Okay. Now the thing that's going to actually have the camera move, private void late update. We're going to use the late update function. This method kicks off after all the other things in the scene have completed themselves for a frame. So everything would have moved into place, etc. Then after all that's done and the frame is ended, it's just finished being rendered, then the last thing we call in the event chain is late update. So that's when we want to move the camera. So here we'll say if move to is not equal to null, somebody set move to in the inspector, then we'll have the camera move. So this dot transform, because this script is going to be on the camera. So this dot transform position of the camera will equal vector 3 dot lerp. So lerp is a special function that it moves from this transform dot position where the camera is to where we want it to go to. Move to dot transform dot position, and then we can tell it how fast to change from one position to another, and that's where the move speed comes in. Move speed times time delta time. Okay, so that will be the camera's movement. Now we have to do the camera's looking at. So if the look at was defined in the inspector in Unity, if the user gave a look at, then we'll do quaternion. The rotation target will be quaternion.look rotation. That function is very nice because it just gets you all the angles for something to look at something. So it's the look at dot transform dot position minus this dot transform dot position. So we want to get the angles so that, we're looking at the target. So that's the look at minus the position of the camera. Then we actually start turning the camera. This dot transform dot rotation equals quaternion dot rotate towards this dot transform dot rotation. That's where the camera is rotated to where the camera we want it to rotate to, and how fast. Look speed times time delta time. Bam. So this could be our camera control script, and I got a little problem here because that should be equal. And these are grayed out, so don't need those. Could take those out. Save. And in the car, I also had those grayed out. I don't need them, so I could take them out. Just press my delete key. Save. All right, so now I got my 2 scripts. Let's go back to here. And on the camera, here, I select the camera, and I'll drag the cam follow script onto the camera. Now you see here it's looking for the move to and the look at. So the move to is going to be my car's move to dot. I'll drag and drop it there to tell the camera to move to that purple dot. And then the look at, what does my camera want to look at? It wants to look at the car. So I'll just drag the red hot car and put it on the look at. Now if I press play, I should have a camera that follows the car around the track. Okay, good. So we got that working. Now we just need to get to the tutorial and start doing the sounds. So let me just shrink this window down a little bit, because here on the desktop, I did have the two sounds that we made. So it's time to bring them into the Unity project. I'm going to bring them into the Unity project, and I'm going to put them in a folder called Resources. This step is important. You have to put them in a folder called Resources. And that's because the Unity scripts can load stuff from a resources folder. File, save. Now I can go back to big screen since I dragged the files in. So let's remember, we call this car engine 02, car start 02. Those are the names of the two audio files. And I'm going to load my audio files via script, via my car script. So let's go back to the car script, and let me just collapse to the definitions here to simplify. So I'm going to have a lot of sounds that my car is going to make. So to kind of keep things a little bit more organized, I'm going to make a class within my class for the sounds. But the variables here, they will be system serializable, so I could see them in the inspector window and actually set the values in the inspector window. So I'll call this class CLS sounds. And I think the first thing I want is a public string, the file name for the engine, which I'll set here by default to my car engine 02. Now I don't put on the extension, because here in Unity, if I look in the resources folder, you see it says car engine 02 dot mp3, but in the Unity script, the name is going to want to know just the name of the file without the extension. And the other sound I have is public string file, what was it? Start. And I know the file I'm using for that sound is car start 02. Okay. Then I'm going to want to have my actual audio sources, the audio source components. So I'll have a variable for them here, audio source, and I'll say AUD for audio source engine number 9, null, and I'll have a public audio source audio start for the start sound, no, okay? And these I want them to be public because I want them to be accessible within the script from outside of the class, but I don't want them to show in the inspector. So I'll say this, hide an inspector on that variable and hide an inspector on this variable. All right, so we're going to need now in my car class, I need a variable for this sounds class thing. So I'll say private CLS sounds, and I'll call it SND for sound, equals a new CLS sounds. Okay, so I'll have a variable for it now. I'm going to have to load the sounds. So the sound loading functions, I might also put them in the sound class themselves. So here I had some variables, but now I'll make a function, public audio source. It's going to load the audio source onto my game object, right? Create audio source, I'll call it. So it's going to take the file name, and then it's going to take the game object that has to load the audio source to. So that's the parent game object. And let's see, audio source, I'll just have a variable in here, AUD will equal the parent game object dot add component. I need an audio source component added to the game object for this sound that I'm going to load. Okay. Then I need to load the sound into the audio source. So audio source dot clip is where the sound's going to get loaded into. And there's Unity class called resources. This is why the folder had to be called resources. Dot load. And what I'm going to load is an audio clip. Okay, and the name of the audio clip to load is the file name. Okay, so this will add an audio source component to the game object, right? So here's red hot, And if I were to add a component, where's audio? Audio and audio source. Okay, that's an audio source that I added manually. Let me remove that. So this line here is going to do that. It's going to add the audio source via script. Then the sound that the audio source is going to have is going to be loaded up with this thing, and it's using the resources class. That's part of the Unity engine.resources. Okay, that's part of Unity engine, and it's just a load function. I'm loading an audio clip type. I just got to give it the file name. And what that requires is that the files be in the resource, a folder called resources. All right, so that's why we had to make a resources folder, and I put the 2 sound files in there. And then I just had to give it the name of the file. So hopefully that works. Let's test and say if aud.clip equals null. That means it didn't work. The sound didn't load. Then we'll just put a little error message. Debug.log error string.format error audio source clip did not load, and the file name that you supplied equals that's the first parameter, and the game object that we tried to load it on equals, and that's the second parameter. So the first parameter is the file name, and the second parameter is the parent dot name. Right, that'd be some useful error information in case the sound didn't load. We could see it in the console of the Unity. I forgot the semicolon. Enter. Audio is loaded. Now we just have to return the audio source, right? Because this is the returning value. So return AUD. Boom. And we made a function for creating an audio source. Yay. Now in this class, let's also make a function to load all our sounds. So I'll say public void load sounds. Okay. So here in this class, we know what the sounds are. I'll load the sounds. So the first sound I will load is the audio engine. So aud engine equals create audio source. What's the file name? It's file engine. Oops, I'm gonna need what the parent game object is here. So game object parent. So I can pass it, and that should load the sound for the engine. And the engine sound, aud engine, that loop should be set to true. Okay. Then the other sound we're going to load, aud start, is going to equal create audio source file start parent. And aud start loop is going to be false. It's not going to loop. All right, so actually load sounds calls create audio source. Load sounds has to be public. And here create audio source, that could be private, meaning that it's only going to be seen within this CLS sounds. Okay, and we have the sound variable here, right? And in the start, we just have to call sound.loadSounds. Or is it load sounds or load sound? What did I call it? Load sounds. Oh, I have to give it the game object. So that's this dot game object. There we go. Oops, let's spell that right. This dot game object. Case sensitive. Boom. And let's play the start engine sound right off the back. Aud start dot. Oops, I gotta say sound class. Sound dot audio source start dot play. Boom. So now we should hear a sound when the game starts. Listen, everybody. And then it stopped because it only plays once, it doesn't loop. So what happens is the game starts, the car is going to start, and then we want to have the sound play for the engine, the normal engine noise. So let's use an invoke function. So we're going to write a function over here. It could be private void play engine sound. And then here, all it has to do is say sound dot aud engine dot play. And it's already set to loop. But the reason I made a function for it is so I could use invoke and start the engine playing sound after the start sound finishes playing. So I'll say invoke the play engine sound function, but do it after sound dot odd start dot clip dot length. And then maybe, so it doesn't wait till the end of the clip, I'll just say times 0.8f. Like when the start sound is 80% done, because this is the length of the starting engine sound, but 80% of it, then call play engine sound so the engine sound will start playing. Okay, so first I'll load all the sounds, then I'll play the starting engine sound, and then I'll wait until the audio start is 80% done, and I'll call play engine sound, and then play engine sound will play the engine sound. So this is what it sounds like. It should sound like a car starting up, and then we're just going to hear it idling. Okay, so far so good. We got the sound playing. But now we're going to have to play around with the pitch of the sound so that the car could sound like the engine is revving up or revving down. All right, so we're getting there. We got the engine sound, we got the car starting, then we got the sound of the car with the engine idling. Now, let's think. Where do we control the pitch of the engine? Well, here's where the car moves in fixed update, okay? Here's where we did the movement for the car. So the movement just finished here. We added the relative force for the car. Let's do a function after the controls for the car. Let's just, so it's not all here in the same function, let's do a function for, let's call it do sounds. Okay, do car sounds, I guess, I don't know. All right, and then we could just come here and write a function, private void do car sounds. First thing we have to know is how fast the car is moving. Float magnitude mag equals rigid dotty dot velocity dot magnitude. Okay, so that's going to be how fast the car is moving, the velocity of the car. So this magnitude is basically, let's rename this to car speed. Got the car speed, it should be simple then. We should just say that the sound.odd engine dot pitch, engine pitch, we're going to change the pitch based on the speed of the car. So 1, a pitch value of 1 is the sound playing at 100% speed. If we are moving, then we are going to be 1 plus whatever the speed of the car is. And I think the speed of the car, we're going to have to figure out how fast a car could go, because we're not going to multiply the sound times 30, but we're going to use the car speed somehow, and probably have to, well, we're going to have to see how fast the car actually goes. So hold on a second. Let me just comment that for a moment. And let's put something on the car so we can tell how fast it's moving. So let's put a label on the car. Let's use a 3D object, TextMesh Pro. Okay, it's the first time we're putting TextMesh Pro in a project, so we have to import the essentials. Da-da-da-da-da-da. Yeah. All right, so we added a TextMesh Pro object to the car. It's huge right now. Let's shrink it down. So here we'll just say speed, because we're gonna, I guess it'll be a number like 97 or something, and right now it's like over in the corner. Let's control the layout. What do we got here? Let's center it, and let's center it. Okay, this box is way too big, so let's shrink that down. The width 4, the height 1. Okay, the width 3, the width 2. That looks better. It's in the middle of the car. Let's move it back so I can just see it as the car is driving. We can see what the speed is. Okay, now let's label this thing. Let's call it the car label or something. Car label. And now here in the script, we're going to have a reference to it. So a reference object would be private TextMesh Pro. I think this is the object car label. We're going to call it equals null. All right, so you see TextMesh Pro is underlined in red. The script is, C# does not know what this is yet. The script doesn't know what this is. So put my mouse over the squiggly line, and right here, show potential fixes. Let me click on that. and I could add using Text Mesh Pro, TM Pro. So I click that, the red line goes away, and up here it added using TM Pro because Text Mesh Pro is part of class TM Pro. But that took care of that. Now we know what car label is. Now in start, we have to define car label. So here I got the rigid body. Then let me just get the car label. Car label will equal this dot transform dot. I'm using this transform because it's a child object of my car. I made it a child. The name of it, I'm looking for the object called car label. And then after I get that object, then I want to get the component from it called Text Mesh Pro. Boom. Okay, and then where am I going to set the speed? Probably here where I get the speed. Here I have car speed, right? So here I could say car label dot text equals car speed. Let's see, string dot format 0 comma car speed. And let's let's see. Oh, the car speed is going to be a float. So let's format the car speed number to a string where we don't have any decimal places after. It's just the whole number part. Okay, play. Let's see if this is playing. It looks like 36 may be the max speed of this car. So here, let's make a variable. We're talking about sounds here. So let's have a private float max speed equal 36. All right. Now with the max speed of 36, I know how fast the car could move at maximum. So whatever, the pitch is 1 plus the car speed divided by 36 f. So the closer it gets to 36, the larger the value is to 1. So it's 1 plus 1. So it's going to go from 1 to about 2 for the pitch, right? So let's see what that sounds like. Go back to Unity. Oops. Press play. Okay, so you can see that the pitch goes up when the car goes faster and it goes down as the car goes slower. So that's a basic car sound, but let's add in that the car has gears, and when the car has gears, the sound will go, the pitch will go up, it shifts gears, the revving goes down and then goes back up again, it shifts gears, and so with car shifting, right? Unless we have a one gear car here. So how do we do gears? How do we do gear shifting? So what we're going to do for gear shifting, let's go to our sound class and add some more variables here. Wait, did I say max speed in this thing? Oh, I just put 36. I should have said sound.max speed. Sorry about that, guys and girls. Sound.max speed, and I said private. It has to be public. Oh, yeah, the CLS sounds, these things are public, right? And that's good because I'm guessing numbers here, but when they're public, when the class is public with a system serializable, here in Unity, if I click on the car script, it should be showing that stuff, but it should be showing. I made this private. Okay, I have to make this public. Then I could show it in the inspector window, so we could change the values if we have to, easier than changing them in the script. Okay, now it's public. So now in Unity, the car script should show the sound. See, now we could have the name for the file engine, the file start, and we can say what the max speed is here. Okay. Oh, all right, so we're going to add some more variables here. Well, we're going to add this could it be private? Let's make it public. Int gear, what gear the car is in. But this variable we're not going to show in the inspector. It's going to be controlled from the script. And then we're going to have public float. It's an array. Gear ratios. Okay, and that's going to be an array of floats. And I'll initialize the values for now to 16 and 34. Ooh, 34. Maybe that's too, it's never going to reach 34. well, okay, it's going to shift gears at 16, and it's going to shift gears at 34. It's going to shift gears at 16. Well, we'll see what happens. Okay. Shoot, 34, maybe like 30, 30, 30, 30? No, maybe like 28, 16 and 28. The two, I'm gonna have it, the car's gonna have 2 gears, okay? And it'll shift it when it gets to speed 16, the gear will shift, and when it gets to speed 28, the gear will shift. All right, so that's some variables I added, gear and gear ratio, and how I use gear and gear ratio in do car sounds. Let's think. So this is gonna be, what is the gear? So this is the speed of car. We're gonna have to loop through the gear ratios that we have for in I equals 0, I less than sound dot gear ratio dot length I plus plus. So we'll loop through all our gear ratios, trying to find out which gear our car is in, what speed are we at. So gear, if sound gear ratio at I is greater than the car speed, then, okay, so I'm going to go through all the gear ratios. I have 2 of them, 1 and 2. When I find a gear ratio value that's bigger than my car speed, then if the gear is less than it, then make the gear equal to it. Okay, so that's going to find my gear. What gear is my car? What gear should I be in, right? Whew. Then I have to have the pitch or the rev based on the gear ratio now. So I'll have a float value for the gear min, and I'll have a float value for the gear max. And if sound.gear equals 0, then I know that the gear min equals 0, and the gear max equals the gear ratio at sound gear. All the other gears, it will be gear min equals sound dot gear ratio at sound dot gear minus 1. 2, gear max equals sound dot gear ratio sound dot gear. All right, so that's everything typed right. Okay, so basically my speed range is based on the gear. Speed range is based on gear. Yeah, the min max of my speed ranges. So here, what's the speed? Then what is the gear? Then what's the speed range based on gear? Now, am I ready to do the pitch? So now, the pitch, the engine sound pitch, float pitch is going to equal the car speed minus the gear min. Okay, that's going to be the first number. Divided by the gear max minus the gear min. That's the range of the speed. And this will give me a linear value. And then I could say 1 plus pitch. Bam. Let's see what that sounds like. Play. The pitch went down. Oh my god, something's wrong. We were seeing the speed, and that 97 is so wrong. Let me just take that 97 off the label and make it 0. Also, the font is too big. Okay, file save. 0, 0, 0, 0, 0. So something's wrong. I did too many things at once. The gear. Let's take this car label text here and cut. And let's use that to give us information here, the car label. So right now I have 0, and that was the car speed. Let's add another number there. 1. Let's add the gear, comma, sound.gear. Okay. So let's see the gear and the car speed, all right? Oh, but it's going to be from 0 based, so let's just add a 1 to it. Let me just see if that can help me figure stuff out here, because the pitch just dropped so low, right? And I didn't hear the pitch raise up and drop. I'm in gear 2. See, why was I in gear 2 already? I should have been in gear 1. So here something's wrong. Let me think. I'm looping through the gear ratios. I have 10. I'm gonna have one at 34, 16 and 34 gear, car speed, and here I'm. If gear ratio at I is greater than car speed, thinking out loud. Oh, get rid of that stuff here. Cut, paste. Here. I had that extra if in there. I was thinking of something else. All right, so if it's greater than car speed, then change the gear, jump out of the loop. For that gear, what's my min max? Get the pitch. It's a linear value. Boom. Okay, ready? Let's try that again. Gear 1. Okay, good. We got that, and the value is linear. What I mean by the value being linear, if I were to graph the changing of the pitch, it's a diagonal line that goes from the minimum pitch to the highest pitch. But I kind of want the value to kind of not be a line like this. I want it to go like at an arc. So I'm gonna do some math to it. So the math that I'm gonna do to it, I'm gonna use the internet and its greatness. So let me see, online graph. Let's see, online graph calculator, Desmos. Okay, so here I could have a graph here. So y equals x. Y equals x. You see that's linear, right? Y equals x square. What? How do I do x square in this thing? Y equals x to the power 2. And that arcs up. Y equals x to the power of 0.5. And that has the kind of curve I want, like this for the pitch. So I have to put x to the power of something between 0 and 1. So here, after I get the pitch linearly, then I will get the pitch like at a curve, right? So pitch will equal that 1.0 plus 1.0, yeah, plus math f dot power to the power the pitch, and I have to do it at 0.5, and that should give me a curve, right? So this is linear and this is curved. Okay, all right, so save, and this one value, I have it in 2 places. It's going to be important. So let me make that another variable in my sounds. Public float. So what kind of value? Oh, it's the base pitch. Base pitch equals 1.0f. Okay. Here I could say sound dot base pitch. Sound dot base. So let's go ahead and see what that sounds like now with a curved increase in pitch instead of a linear one. Car accelerates really fast. So let's see if we change the gear ratios on the car sound. Here we have 2 of them. The first one's 16, and then so let's make it go to 20, and then have this one be 36, or 24 and 36. Okay. I mean, I could add more gears too, but I'm just having two so I could just hear the change of the gear. There was one thing, I was able to start moving the car before the start engine and the engine sound was playing. So maybe to prevent me from doing that, let me do a private bool b can move equals false at first. So here in the fixed update for all this movement stuff, don't even worry about getting these if I can't move yet. So if b can move equals true, then I can go ahead and do all this movement cut, and I'll have the can move equal true when I play the engine sound. So b can move equal true. Right, so initially the script starts, it's false. Where is it? Here it is, it's false. And then after the engine sound plays, then it's true. All right, so here we go. So press play. All right, so that's how we do a car sound with gear changing, with a increase in the pitch that kind of dies off a little bit as you go faster. You know, so you could hear the change in the initial gear shift, but then as the engine revs faster, the pitch changes slower. Okay, so the magic is basically here in the do car sounds function, where I get the speed, which is the rigid body velocity. Then I figure out what gear it is from my gear ratios. I loop through until I find the gear, and I could do that. And then once I have the gear, I could get the min-max based on that gear ratio start and end speed. And now the pitch, use this. This is the range of speeds, and this is the speed within that range of the car. So that's a linear value of pitch. Then I take that linear value of pitch and I kind of put it to the power of 0.5, which makes it a curve. And that's how I get the engine pitch sound. And then I have this displaying the gear and the speed. Okay, so the car has the sounds of revving and starting. And the car also has gear shifting. But let's add a sound to when the car shifts gears. So here in my resources folder, I have the car engine rev and the car engine start. And, you know, maybe I could fine tune those a little bit more, but right now they're fine for me. And what I want to do is get some shifting sounds. So let's see, I got my car engine sound from a video. Car gear shifting sounds. Car gear shifting sound effect. Okay, this is 15 seconds. So let's copy the video URL and go to this MP3 download 2 website. And how do oh, here we go. Let's put the URL here, paste, and search. I just want to try this 128 one, see if it works. So I click download. Yeah, so it looks like it'll do the different qualities. And I'll download it now, and I'll just bring it to my desktop. Okay, so let's see. This is the shifting sounds. So let's start to edit them out. And they're very, very tiny. Okay, let's play the sounds here, see how they sound. Kind of low compared to my other sounds. So let's just do the effect amplify. Oops, I gotta select all, Control A, then effect amplify in Audacity, and now we got a bigger sound. So probably the sound's not going to be that loud in comparison to the engine noises that I have. So let's just change the, would it be amplify? And amplification, just put it down. Let's see about that. Well, let's try it at this amplification. Now, there's multiple shifting sounds here. So, let's hear this one. I'm going to pick one for my shift up and one for my shift down. I'll pick this one for shift up. I will do a view, zoom to selection. Okay, so now I could get a very close copy. File, export as an MP3. Let's just put it right into my folder. C Omar Unity Car Engine Sounds 2 Assets Resources. So let's call this car shift 1. Save. And then let's pick a different sound, so I can tell the difference between shifting up and down. Zoom to selection again. So we pick that one. What about this first one? Let's zoom to this selection. I think if I just pick this and this without the second noise, maybe I like that. Shift play. Okay, so let me export. File, export selected audio, and this will be my car shift 2. And the reason I'm gonna have 2 shift sounds, one shifting up and then one shifting down, I guess, Alright, so I got my shift sounds from that YouTube video. Alright, I can close this, and then in my Unity project, for the shift 1, look, for shift 1, it exported the whole file, so I have to do shift 1 again. Hold on. Let's go back. Car, gear shift. Open up an Audacity again. Control A, effect, amplify, effect, amplify by 10. Amplify a little bit more. Repeat it. Okay, so, is this the first sound? Right? Ooh, that's a little too loud. Amplify down. From 10, let's say that much. Let's say it's like this. Alright, so now this is the selected. So I say File, Export the selected audio for shift 1. Replace. Okay. I'm not going to close it this time. I'll leave it open. Now I go back into Unity. Let's see the first sound. And the second sound. Okay, cool. So I got my 2 shift sounds. Now let me go to the script again for the car. And let's tell when to play those shift sounds. So here is what is the gear. And right here is where I change the gear. Okay, so if I'm changing the gear and the gear is going up, I'll play shift 1 sound. If I'm changing the gear and the gear is going down, I'll play shift 2 sound. My sounds are loaded with my CLS sounds class, so I'm going to have to make some variables. Public string file shift 1 equals car shift 1. Then public string file shift 2 equals car shift 2. Okay, now I need some audios for that, audio sources. So hide an inspector, public audio source, auto shift 1 equals null. And then hide an inspector, public audio source, odd shift 2 equals null. Okay, and then the load sounds function to load my audio sources. So odd shift 1 equals create audio source, file shift 1, comma, parent. And is this going to loop? It's not going to loop. So odd shift 1 dot loop equals false. This would not be a looping sound. And then odd shift 2 equals create audio source, file shift 2, parent. And it's not going to loop either. Shift 2 dot loop equals false. Okay. Now we have the sounds loaded. So now here in my do car sounds, it's like, okay, here my do car sounds right here where it changes the gear. This is where I'm going to play the either shifting up or shifting down. So I'm changing the gear here, right? So if sound gear dot, no, if sound dot gear, if my current gear is less than I, then I'm shifting up. I'll play the shifting up sound. Sound dot odd, and I'll say my shift 1 is shifting up dot play. Else if sound dot gear is greater than I when I'm changing the gear, then I'm shifting down. Odd shift 2 dot play for the shifting down, and then break. Okay, save. So now I have some sounds here for shifting, so that'll be a little bit more sounds to hear from my car. So let's try that. Okay, give us play and turn on your the shift sound sounds kind of low. I couldn't really hear it. Then I'll have to go back to edit the sounds. So let's see. Okay, File Explorer, Car Engine Sounds 2, Assets, Resources, and here's Shift 1. Let's make it louder. So open with Audacity. So what I'll do is I'll just amplify it. Oh, I got it. Control A, select everything. Effect, amplify. Let's amplify by 5 at a time. Okay, and I think we could do one more amplification. Amplify again. Okay, now let's export that as an MP3. Car shift 1. Save. Replace it. Alright, now for car shift 2, let's do that one. Control A to select it, then effect, amplify by 5 at a time. And let's try that again. Repeat amplify. There. File, export, MP3, car shift 2. Okay, so now the sounds are amplified. Let's go ahead and try that out. So the sounds are amplified here. You can see. Let's play the game. See how the sounds sound if we could hear the shifting sound. Right there. I do hear the shifting sound. It's just kind of like, it's back there. So I guess if I wanted to hear it more, I can make it louder. Now there's another sound here, the start sound. You see the idle right there sounds like one thing. Here's the car engine. Sounds like that. But listen to what happens when I press the game to play. It plays the start sound, then starts playing the engine sound, but the engine sound, the pitch is higher. Hear that? So something's up there. Something from the code I did before. And the engine pitch is coming in right here. This should be pretty much the bass pitch when the game starts, but it's not. It's, I think because I added sound bass pitch twice. See, I added pitch equals sound bass pitch plus to the power or something. And then over here, the audio engine pitch equals bass pitch plus again. So maybe that's why. That's a mistake. Let's take that out. Now let's press play. Okay, I also think that the car start sound with all this extra boom, it's kind of like too much and it doesn't blend in well to the car engine sound. So let's edit that and take off a little bit of that. So shrink that, shrink that. I have to find my sounds again. Unity. Strong Unity folder. C. Unity. Car engine sounds and assets resources. So that's my car start. So let's open that up to edit in Audacity. Yeah, so all this part, let's just hear it out. Here's the start. I think I could delete off that beginning part. Boom. And then after boom, it kind of just goes into the, all this is like just idle. I'm going to take that off. Boom. And right here, let's take this part and let's fade it out. So I'm selecting that part and effect fade out to nothing. All right, so now if I play the start engine sound, there. Okay, so let's save this file, export MP3 as the start, replace it, and I know it's going to fade out. So where do I start playing it? I start playing, okay, these are going to be my helper classes up here, so I'm going to make a thing called a region just to organize better. Helpers, and then end the region. Okay. Boop. That way I can always close that up. And I think in start it plays the start engine sound, and then over here start when it's 80% done it starts playing. Okay, so let's try that. It does have a little bit of blend time there. So let's hear how it sounds. Darn, it faded out and then it started the engine sound. So maybe this time right here, give it a little bit more. Let's give it 60%. 60%. Then it starts playing the engine sound. And let's see how that sounds. Yeah, that sounds better. So since that variable time here, it's going to depend on my start engine sound and the engine sound. Maybe I should make this a variable in my CLS sounds class. Oops, I said region, too much stuff over here. Sorry. It's just for my helper stuff over here. These variables are part of the class. All right, in the sound class, I'll have a variable for public float start to idle lead time. And right now, I have it set to 60%, right? So this start to idle lead time, copy, I'll put that here instead. That way, if I have some different car engine sounds, I could play with that without having to change the code. So each car could have its different lead time. All right, there. Shrink and shrink. So what do I have now? Let's check it all out. Let me save this. Right now I have the start engine, the engine idle and revving, and then the shifting sound, which is kind of faint in the background. Let's just give it a run through and check to see how those sound again. Okay. Whoa, the car flipped over. All right, so the car flipped over. I don't have anything to put the car back. Let's add some code in here to flip the car back when it flips over. So here are my helpers. I'm gonna have to have something to detect when the car is not the wheels on the ground. Okay, so when the wheels are not on the ground. All right, so here, let's add some variables for that. I'm gonna put them together in a struct for everything about keeping the car straight up. Okay, I'll use a structure instead of a class this time. It's a little bit less intensive. So I think I'm going to make an enum called wheels down to tell me how are the wheels down. So I'm going to have an enum over here, private enum wheels down, the different states of my wheels down. So the car is either it's on the road, it's on the road like it's supposed to. So how'd that be 0? Oops, 0, comma. And another enum will be it's on the grass, which I'm going to say it's off the road, like it came off the racetrack. And then the second one, the third one is the car's flipped over and I need to actually flip it back. So I'll say 2. So here are the wheels down in my structure flip. It's one of those enums, like the state of the car. And when the car flips over, I'm going to give it a chance to stop rolling over and stuff like that. So I will have to have a timer. How long do I wait for it to stop rolling? Public stop rolling, and that would be a float. Stop rolling time. It's a float. If it did come off the road, I'm gonna have to remember where it was on the road. So public vector 3 left road position, let's call it. And so I could scan the car from the center of the car down to the bottom. How far do I scan to see if I can find the road? I'll need the bounds, the render bounds of the car. Then I'm gonna need a variable, right? So private struct flip, and I guess I'll just call this flip, okay? This is gonna keep track of things for me for flip. Oh, since I'm gonna wait for the car before I flip it, I'm gonna be using an invoking function. So I'll have a public bool be invoking flip, invoking the flip, so I don't call to invoke it multiple times. Dang, and some of these values, they're gonna have default values. So gee whiz, you know what? Let me just do a class. Public class CLS flip. So wheels down by default, I'm gonna say it's on the road. And then invoking flip by default, I'll say false. Stop rolling time, I'll give it 1 second to stop after it stops rolling. Okay, so here it's going to be CLS flip equals flip, which is a new flip class. Okay. Then here in the start, I have to get the bounds. So flip dot bound equals this, the car dot get component mesh renderer dot bounds. There. That gives me the bound object. So with the bound object now, every time there's a fixed update, right? Something happened to the physics update. I do the car sounds. I could also check for, is the car flipped over in the physics update? Is the car flipped over? Or are the wheels down? So is wheels down? I'll make a function for that. That's going to check to see if the wheels are down. So is wheels, oh, here we make the function. Private void is wheels down. Is wheels down? So basically what I'm going to do to check if the wheels are down, the car, all right, you could say from the center of the car, I'll cast a ray down, but I'll just cast a ray down to about where the wheels are. So if the car is up in the air and I cast a ray down to here and the road's not there, I'll say the wheels aren't on the floor. That also works for if the car is flipped over, I cast a ray from the center of the car down in respect to the car. If the road's not there, then the wheels aren't touching the ground. You get it? So that's how I'll be able to tell if I have to flip the car over. So now I just have to write the code for casting the ray down. So here in the is wheels down, I'll have raycast hit to get the hit information, and then I'll cast the ray. If physics dot raycast from this transform dot position. So I need it relative to the car, so I need to use the car's transform. This dot transform dot down. There's no down. See, it says detached. So this transform dot up. All right. So minus transform up is down relative to the car. And how far do I go? Oh, I need to give it the out variable. So out, it's going to put it in the hit information. And how far down do I go? I go flip dot bound dot size y. Okay, that's how far down I go. But I want to go a little bit. I don't want to go all the size y because the center of the car is where I'm casting from. So I need like half of that. So that would be 0.5. But then I'll just give it a little bit more. So to make sure the road's there, 5.5 f. Okay. And oh, I need two parentheses. If it's an if statement, and now I'll do these conditions. If this is true, if I do hit something, okay, if the raycast does hit something, if it's true, then I'll see what I hit, and the things that I could hit, if I look here in the scene, remember here's my track, so I have the gravel on the 1 and the gravel 2, I have the road 1 and the road 2. All right, so if I'm on any of these gravels or roads, the wheels are down, and that's like a certain condition for me, so I'll check for that. If hit.collider.compare tag to my Ooh, what are the tags, actually? Let's see. Oh, they're not set. Okay, so barrier 1, let's set all my tags. Oop, I didn't even make tags. So I'll say barrier 1, save. Barrier 2, save. Or maybe I'll say barrier left and right. Darn it, now how do I get rid of those? Get rid of it, get rid of it. All right, so barrier left and barrier right. Save. Then I have gravel left and I have gravel right. Save. Then I have road left and road right. Save. While I'm at it, I'll make a tag for a car. Save. Okay. So now here barrier 1 is on the left. So this is barrier 1, barrier left. Barrier 2 is on the right, so this is barrier right. And this is gravel left. And this is gravel right. And this is road on the left. And this one's road on the right. And my car is my car. Just tagging stuff. And I'm also, so I don't scan everything in the scene, I'm also make some layers too. So let me add a car perception layer, things that I want the car to be able to see. And then I'll put all these things here on that layer, and the car, I put it on the layer. Because if I have more than one car, then the cars could see the other cars. All right, so I just took care of my tagging. So now here, when I cast the wheels down, I could see if I'm hitting the, oh, it's going to be a couple of things I could hit. The gravel left, compare tag gravel left equals true. And I'll just use a different line. Hit dot collider dot compare tag to gravel right equals true. I'm going to check all those different pieces of the road. Hit dot collider dot compare tag road left equals true. And the fourth thing, hit dot collider dot compare tag to the road right equals true. So if I'm on the road, you know, that's the way I want everything to be. So my flip dot wheels down, I'm going to set it to equal wheels down dot, it's on the road. I like it. Okay. Then I guess if I'm not on the road, else, then my flip dot wheels down, because I did hit something. You see, it's still true. Wheels down, it's not the road, so I'll say wheels down dot on grass. Or more accurately, instead of calling this enum on grass, I should call it not on road. So let me just rename that. Not on road. Okay. Or I should say on, let's rename this, on non-road. I'm on the road or I'm on a non-road. Okay, that could be grass or whatever. So that's if it's true. If the physics raycast down and it doesn't hit anything, well, guess what? The wheels are probably flipped over. So my flip dot wheels down is going to equal wheels down dot the car's flipped over in some form or fashion. Okay, so this is wheels down thing is going to tell me how the car is. And I guess I could return the wheels down value from it. Return flip dot wheels down. So I could use it like in an if when I do the is wheels down right here. Alright, so what do I do if the car's wheels aren't down? Think, Omar, think. Let's do a switch statement. Switch is wheels down. So case wheels down dot on road. That's good. Nothing to do there. Case wheels down dot on non-road. The car can still move. Case wheels down dot the car's flipped here. This is where we gotta do something. So if the car's flipped, what am I gonna do? I have to flip it back over. So first thing I have to do is make sure I didn't call to flip the car over yet. So if flip dot be invoke flip equals false, then I could go ahead and call to invoke the flip. So here I'll set the be invoke flip equal to true, so I don't call this again. And then I'm using an invoke, so I don't have it make wheels down as out of a function, comma, flip dot, is it stop? Ooh, flip dot, my stop rolling time? Yeah, so flip dot is like car flipped time, I guess I'll say. I'll rename this to car flipped time. The amount of time I let the car be flipped over. I have to make another function now. Private make wheels down. Oh, private void, sorry. Make wheels down. First, since I'm here, I will be able to call this function again. So I set this thing to false so I could call again. If the car is flipped, I have to put the car back. The car is flipped, I have to put the car. So let's call this reset car. Rename. Reset car. Okay, so right here, I'm gonna have to call this reset car. So if the car is flipped, I'm gonna reset the car. Also, if the car came off the road, I'll have to reset the car. Invoking reset. This is what this is really. Rename. Be invoke reset. I can change the names of functions and variables. So over here, if I go off the road, I am also going to have to reset the car. So basically, here, these two conditions. If the car's on the road, great, don't do anything. If the car's off the road, for simplicity's sake, I'll just duplicate some stuff. They may be different conditions. So if the car goes off the road, reset the car. If the car is flipped, reset the car. So here in the reset the car, I have to see which condition is it. So I'm going to switch on the flip dot wheels down condition. And here again, I'll be checking case wheels down dot off the road and case wheels down dot I flipped. So let me work on the flipped one first, because that's kind of like what I have in my head right now. So if the car is flipped, if the car's flipped, if the car's flipped, if the car's flipped. Here, be, okay, I'm going to call the invoke. I'm going to call the invoke after a certain amount of time. First, I want to make sure the car's not rotating anymore. It's not rolling. RB.angular velocity dot magnitude is greater than 0.1. It's still rolling. Then break. Else. Yeah, so this is the check. Is the car still rolling? Okay, if I get to this point, then the car has stopped rolling. So rb.velocity vector 3.0. Why am I doing this? Make sure the car's not moving. And this dot transform dot position equals the position that I left the road. Left road position. So I'm gonna have to know where I left the road. I'll know where I left the road. On the collision exit, right? So private void on collision exit. So here, if collision, I could kind of reuse the stuff I used on the is wheels down with these tags. So if I have to type if collision dot compare tag dot game object dot compare tag collision dot game object dot compare tag gravel right equals true, or collision dot game object dot compare tag road left equals true, or collision dot game object compare tag road right. If any of those happen, then I'm leaving the road and I want to remember where I am. So my flip dot left road position is going to equal vector 3 this dot transform dot position dot x this dot transform dot position xy this dot transform dot position z. So that way when I get down here to reset the car, I could put the car back in that position when it left the road. And what else am I going to do? And then I'm also going to Euler rotation. I want is going to, oh wait, I need a Euler rotation variable vector 3 Euler rotation. Okay, so here Euler rotation is going to equal transform dot rotation dot Euler angles. That's the rotation. Whatever it's flipped to, that's its flipped rotation. And whatever that rotation is, I'm going to set transform dot rotation quaternion dot Euler. I'm going to set the rotation of my object but using Euler angles. So I'll say the Euler rotation dot x, the Euler rotation dot y, and 0 for the z. See, because if the car is driving along here, right, if the car is driving along here, right, and z is the front of the car, when it flips over, it's probably going to flip over, it's flipping over on the z-axis, right? It's rotating on the z-axis so the wheels flip over. So it's that z-axis that I want to put back to 0. And the other angles, x and y, they could be whatever they are. And this will flip my car upright. So this stops the car from moving. I don't think I need that. So this puts the car in position like near the road. This flips the car upright. If my car came off the road, it's actually the same thing I'd want to do. Copy. So both of these, they're going to do the same thing actually. They both are the same actually. So I think I could just do this. Flip the car upright over the last known drivable road position. Wheels down. Okay, so this should take care of my car if it flips over. Now, let's see if my car is flipped over, if it'll get turned upright. Okay, the car flipped back right side up. All right, so we took care of that. I got the shift sounds, I got the car flipping over. All right, now, what else do I want? I think for the car driving, you know, when you drive in a car and it goes faster, you hear like the sound of the wind and like this kind of ambient noise inside a car. So we should find a sound for that. So we could do that to our car too to make it sound more realistic. Let's get some ambient car noises to put on our car. So let's see if we could find some. So far we've looked for our sounds in YouTube videos, and then we've extracted the audio from the video using the mp3 download.2 website. But I do know of this other website for free sounds. It's called freesound.org, right? So let's see if we can find a sound here that we could use. And what I'm looking for is car ambient, rain from inside a car. Inside car, 50-kilometer asphalt. So maybe let's use this one. It's kind of like a low humming noise inside a car. Let's download it. I'll put it on my desktop, save, and let me see if I can find another one. Street sounds, car wave. This one may be good too. I could take a piece of this one. Download. Street sounds to my desktop. Save. On my desktop that I downloaded. Alright. And now, let me try to make space here. So here's the two sounds I just downloaded from freesound.org. So let's open up maybe this one here. We're going to use one of these for the ambient sound. So let's see, what does this one sound like again? Right here. This could be just the noise right there, right? Shifts like. See, there's a sound when you're inside the car. So let's use this one. So let me edit, copy that little segment off, file new. Here, I'll just paste that segment. Paste, edit, paste, edit, paste. Bam. Okay. Now, I think I should amplify. Let's amplify by like 5 at a time here. Okay. Oh, I can amplify more. Repeat. All right, so now that's louder, right? But if it loops, it's not going to sound right. So Control A, edit, copy, then go to the end of the sound, see right here, and then say edit, paste. And this pasted part is selected, edit, reverse. Bam. So now with the reverse, it could kind of loop better. It kind of is like more of a seamless sound. Control A, Shift, space. Good, so now it's a sound that's continuous. So file, save, or file export as an MP3. And what I'll call this is car ambient. And it's going into my resources folder. Save. Here, we should have a new sound, car ambient. All right. Now, in our script, let's get ready to be able to use that sound. So in our sounds class, I'll have a new sound here I'm going to add. File ambient equals car ambient. And I'll have to have the audio source. Hide in inspector, public audio source, aud ambient equals null. And then in the load, I'll have to load the sound here. So in the load, I will load the new sound. Aud ambient equals create audio source, file ambient, comma, parent. And this sound is going to be a looping sound. So for the loop, I'll set it to true. Okay, now let's see when the game starts. We have the sound of the engine starting. Then we have the sound to play the engine sound. And I think when the engine turns on, we could have the ambient sound turn on. Yeah, because you're only going to want to hear the ambient sound when the car is moving. And the more the car is moving, the louder the sound will be. So here. Sound.aud ambient.play. And sound.aud ambient.volume will equal 0 at first, okay? So it's playing and it's going to be looping, but it's going to have the volume as 0. So we're going to play around with the volume as the car's speed increases. Collapse definition. So here in the fixed update is where we move the car. Here we do the car sounds. Remember that? Yeah, I remember that. Okay, so do car sounds. It's getting called when the car moves. So here we have the car speed. We do the gear, speed ranges based on gear, engine, sound, pitch. Okay, so let's do the ambient sound volume based on speed. So here we could say sound.aud ambient.volume equals what? The faster it goes, the louder the volume. So its highest speed and the volume. Is there somewhere in my sounds where I say what the highest speed of the car is? That's CLS flip, that's the wheels down. And bass pitch gear ratio, max speed I have right there, 36. So I could use that. I could say the car speed divided by the sound dot max speed. That should give me a value. And this would be a linear interpretation. And I guess I could make it mathematical, like a curve, like the way I made for the revving. So I could say float volume equals the car speed divided by the max speed. Right? And then the volumetrically set could be math f dot to the power volume of to 0.5. So it's a curved thing instead of just linear. So right when it starts moving, the volume will increase greatly, but then as it's going fast, it'll kind of not increase that much. You're already going fast. Yeah, maybe that'll sound more realistic. Let's try it out. So here I am in Unity. I press play over here. You don't hear ambient sound yet. Now I'm going to start driving. And I'm not sure how loud that is. Let's just have a little debug print. Debug.log, a debug log, I mean. String.format. And we'll just keep printing out the volume here. Sound odd ambient dot volume. So we'll see if it's having any volume. And then also we could see if we need to increase the sound of the ambient so it's even noticeable. Press play. So far it's 0. So it's there, but it's barely noticeable as a sound with the engine and everything. So maybe here we could we could amplify it more. I'm going to amplify it again. Let me do it by like 8. All right, now that's definitely going to be loud. All right, so let's try to save that. Export as MP3. And let's overwrite the ambient sound there. This one's louder now. Yes. Now let's try it again. I just want to be able to hear it. I'm going to try raising the volume a little bit more. Repeat amplify. File, export as MP3. Ambient, save. And now let's try. Okay, good. Now there's one more kind of sound that I want to hear. It's the crashing sound. You see when I bang this to the wall. That's an important sound. And I'm going to get one more sound from freesound.org. Let me look up, and also let me do something else. Let me clean up for the files that I picked my ambient sound from these guys. There we go. Empty. Yes. So now from freesound.org, let me see if I could have a car crash kind of a sound. Let's see. What's this one? How about this one? Ooh, I like this one. So let's try to get this one here. Download to my desktop. And see, this kept going into the wallpaper. I'll just put it to my desktop. Car crash. Save. And there, it downloaded. Now let's take that sound in Audacity. Very nice crash sound. Let's see, so there's a skid before the crash. This part here is like a skidding sound. And then this part here is the crash sound. So we're going to go straight to the crash sound and shift. So we want that. Edit, file, export, selected audio. Here in my resources folder, I'll call it car crash 1, because I could probably have a couple of different crash sounds, you know? So car crash 1, save. Boom. So it should just be the selected audio. And let's see in Unity here. Yep, it looks like just the selected audio. In my script, I could take out this debug. We solved the problem of that. Now we got to add a new sound. So let's see, public string file crash 1 equals, what, I kind of forgot what I called it already. Car crash 1. Car crash 1, right, with a space. Let me just check. Yep. Car crash 1. Hide in inspector. Public audio source. Odd crash 1 is null. And here, add it to the loads. Odd crash 1. Create audio source. File ambient. Oops, file. I'm just copying too much. Crash 1 parent. And this sound is not going to loop. Okay, so now when do we play it? When do we play the car crash sound? It will be when we crash. So it's going to be on collision enter of something. So let's see. Private void on collision enter. So what are the different tags that I have? I have the barriers. So that's barrier left and barrier right. Then I also have, if I hit another car, I want that sound. Okay. So if collision dot game object dot compare tag to barrier left equals true, or collision dot game object dot compare tag barrier right equals true, and or collision dot game object dot compare tag car equals true. Well, by golly, you crashed. So let's make the crash sound. So I will do sound dot play sound dot odd crash 1 dot play. Okay, so now if we hit something, we'll hear that crash noise. Now we press play. Let's see if we get the crash sound. Whoa! I rolled over. That should make a crash sound too. But let's do the crash sound right now and test it. It's way too low. Way too low. So let's do the amplify. Let's amplify it up by 6. What's wrong? It didn't allow that. Let me see. Effect, amplify. Ooh, I have only the selected part. Alright, let's see. Edit. Copy. File new. Edit, paste. Okay. Then effect, amplify. Okay. Amplify again. Let's hear that. File, export as MP3. Car crash 1. Yes. Let's go back to the drawing and hear that and see if it's loud enough. You could hear it, but it's not half as loud as the rest of the stuff. Car crash. Clank. Let's try this sound. Download to my desktop, save. Okay. Open up in Audacity. Okay. Let's try increasing let's amplify it up. Oops, I got Control A. Effect, amplify. Alright. File, export, MP3. as my car crash sound now. Save. Yes, replace it. And here we go. Okay, so when it crashed into the barrier, it made that sound. Maybe a thing that'll help the sound louder too is if the engine stopped playing when I had to crash. So here I play the sound of the crash. So maybe I could have the sound dot odd engine dot stop. All right. Which means that I'd have to have the engine start playing again, or I'd have to have the car start the engine and start playing again. So here I have a thing that plays the engine sound. Let me make one that starts the car and plays the engine sound. So private void play or play start sound. So in the play start sound, it should be like it was when the game started. Here, I play the start sound and then the engine sound afterward. So let me cut that, and here I could say play start sound. And here in play start sound, I'll stick this in here. If the car's not started, I shouldn't be able to move. So where was that can move thing? I had a can move variable. Here, b can move. So b can move equals false. So I can't move the car after I crash. The car has to start, engine has to play, and then I can move. On collision enter. So I'll play the crash sound, and then I'll call play start. So invoke play start sound. I'll do that after the sound dot odd crash one dot clip length. After that sound finishes playing, then the car will restart. Okay, let's try that. That should make the crash sound louder because you don't hear any other sound. The engine won't be running. That makes sense because if you crash real hard, the engine should turn off. Even though, anyway, so how about if you just skid along and hit the edge not too heavy, it shouldn't turn off the car. But uh-oh. I think I forgot to turn off the engine. Sound dot odd engine dot stop. Okay. Play. All right, when the start sound I said can move is false, I gotta move that out of there, and I gotta put it over here. Okay. Let's play. Go. That should definitely be a crash noise. But how do I know when I'm rolling over like that? I know when I leave the road, but the road has pieces, and I leave the road and get into another piece. So how do I know when the car is rolling over like that? And what kind of crash sound would that be? Because that's not, if a car rolls over like that, it's not going to be a, that's like you hit something. So first let's find a sound for when the car kind of is like rolling like that. So here, let's go back, because there were other sounds. There's this one, and that's kind of solid. One of these was kind of long. Maybe this one, that part right there, if I just play this part. Yeah, so let's get this sound here. Download it to desktop, save, and okay. Let's open that in Audacity. And which part of it is it? Is it this part? Right here? It's kind of like this part right here. So edit, copy, file new, edit, paste, and you should just amplify it up. Okay. All right, file, export as MP3. This is car crash 2. Car crash 2. Save. I guess we'll just leave it here for a minute. Think about it. And we have to add it to our helper sound class that we have a new sound. Public string file crash 2 equals car crash 2. Then here we're going to have hide in inspector public audio source aud crash 2. No, and then we're going to have a load sounds, which is just basically the same as car crash 1, but we just use a number 2 here instead of 1, so that'll be a 2, that'll be a 2, and that will be a 2. Okay, now the hard part, how do I know when my car is rolling over? Well, I guess there's a, just like there's a rigid body velocity for the car moving, there's a rigid body angular velocity for the car rotating, right? So here in the fixed update, first I'll have to have a collision exit, or can I just have a car rotating? Let's see. So we'll be in the do car sounds, which gets called from fixed update. So all this part here was about the engine pitch, and let's put that line out to 60. Okay, just make a line. And then this part here is about the ambient noise. Let's just put a little section line there, and let's put another line here because this is going to be, am I rolling? Am I rolling, crashing, right? So the way we'll tell that is rb.angular velocity, okay, dot angular velocity on the x and the y, on the x and the y, x dot magnitude, no, angular velocity x, and just check the angles of rolling. So the z-axis goes forward. If the car is rolling over top to bottom, that's the x, or if it's rolling over on the z. So if it's rolling on the x or the z, those should stay flat on the ground, you know, relatively. If they're not, then I could suspect the car is coming off the ground, okay? X and z are the ones. So for the x, this is my float roll x equals that, and float roll y equals rb.angular velocity.y. And I'm just going to debug print these, debug log these to the screen so I can just see what the values are first. So zeros for the x, I'll say x equals, and then 1 for the y equals, and I'll just say roll x, roll y. I just want to see what the values are when I roll so I can get an idea. All right, now I just have to play and drive the car and look at the console window. So right now their values are 0. Okay, I had a roll in there, right? Let's see if I could tell where the roll was. So along the way, the values do not stay 0. see here the X and the Y, they did have some changes, but then as you come along here, then we had a 3, a 6, and a 9, and a 7 and a 9. These things were moving. They were rolling around. So let's see if I play that sound. If roll X is greater than 1, or roll Y is greater than 1, could that be the number 1? Then print these values here. I'm going to use the rolling speed to tell when the car is starting to roll over. Play. It definitely came off the ground. Well, talking about coming off the ground, I do have the is wheels down, and I have the flip wheels down value, right? So so here I could say and, so it's roll X or roll Y are greater than 1, and my flip dot wheels down is not equal to wheels down dot on road, or equals flipped. And I'll play the sound. All right, so if sound dot odd crash 2 dot is playing, is playing? Yes, there is playing equals false, then sound dot odd crash 2 dot play. All right, so it just plays once. Oh boy, let's see if this works. Okay. Okay, I think it does it, but just like when I crash on the wall, I'm going to have to do something with the sounds. So here is on collision, enter, and I did this stuff for the crash 1 sound, right? So over here, this is the roll car. Okay, so maybe I'll make it simpler. These things for the crash 1 sound, I will say car hit sounds, play car hit sounds. Private void, play car hit sound. And in this function, I could do these three, well, I could do these number of things, cut and car hit, play, right? So play car hit sound, bam. And then I could also do one for play car roll, private void, play car roll sound. And in here, what do I want to do? Well, sound dot odd crash 2 dot play, and then sound dot sound dot odd engine dot stop. Okay, and I'll say you can't move until the car starts. Move equals false. Invoke play start sound. After how long? Let's just give it 1 second. Or do I have anything in my sounds for start to idle lead times? No, bass pitch, max speed. I don't have anything about that, so let me just give it like 1 second. The sound could keep going, but the car, it's just coming off the ground, so I just want it to restart and go. All right, so I had the play car roll sound, and we're going to call that from here. Paste. And it's only one command, so I don't need the brackets, really. It's only one command for the if, all right? If it's not playing, then do it, play it. All right, here we go. Let's try it out. that was the roll right there. So where is it? The play car roll. It waited a second. Let's just do it that it waits for the sound to finish so we could hear it. It's beautiful noise. Dot clip dot length. Save that. Now let's try to have it happen again. Okay, so we got a bunch of sounds, and we got a way to determine if I'm rolling and play a sound, if I hit and play a sound. Now, when I hit the barrier, sometimes I just scrape across it and I don't hit it hard. Should I really be turning off the car just because I touched the barrier? I don't think so. So where do we call that? On the collision enter here, we touch, we can tell how hard we hit, and maybe if we hit it hard enough, then we'll do the noise and the play car hit sound and turn the car off and everything. So if we want to know how hard we hit something, the collision object has information. Collision, ooh, relative velocity, I think it is, dot magnitude. That's going to be a value, right? So float magnitude could equal the collision relative velocity dot magnitude. That's going to be a value. And depending on how hard we hit, we could decide if we want to actually go ahead and do a whole big crash or not. Oh, somewhere I left a debug print, a debug log in there. Let me search for it so I can take it out now. Edit, find, debug.log. I left one in here somewhere. Find all. Here it is in the load sounds. Nope, that's an error. I guess I took it out. Okay, good. All right, so here we have a mag. Now, how hard is it hitting? Debug.log. Let's do a couple of hits and get the values. String.format. And then we'll just print out the magnitude of the hit right there. Okay, and we won't do the car hit sound, so we could hit a couple of times without having it turn off. So I'll comment that out for now for a minute. And go back over here and press play. That was a 20. That was a 34. So the speed that I hit seems to be the speed of my car. All right, so the speed that I hit seems to be the speed of my car. So this relative velocity, that's the entire magnitude of it. That may not be what I need to find. What I may need to find is the, so if I'm hitting and it's on the z-axis, that's like a head-on collision, right? So that will be like my hit z. So it'll be my relative velocity z. And then if I'm hitting on the side, that will be my hit x equals collision dot relative velocity dot x. All right, so now let's try to see those two things. I can have my z and my x. So that will be my hit z and my hit x. Because maybe it'll be if I hit head on, it's like turn the car off. If I'm just hitting on the side, car keep going, okay? So let's see if we can get the difference of those two. Hit on the side. All right, so there is a little bit. When I did the head-on, the z was way greater than the x. And then when I was skimming along the sides there, they're almost the same value. Maybe I could use that information to determine which kind of hit it is. So if hit z is greater than hit x times 2, it's twice as big as hit x, then I could do the play car hit sound. All right. Otherwise, I'm just kind of scraping along something, I'll assume. So I'll have to have a scrape along, I hit something kind of sound. So maybe we're going to have another crash sound that we're going to find. Let's do that. Find another crash sound. This one was kind of cool. It's different. Let me download that. Save. That's the squish. These are the other two. Bye-bye. And empty. Yes. So here's the squish. Just so it sounds different than a hit and different than a roll. Just like that, and just delete all that extra. Okay. And it's gonna have to be loud because the engine's still gonna be running. Amplify. Okay. Control A. Effect. Amplify. That's as big as it can get. File. Export to MP3. This would be car hit 3. Car crash 3. Save. And we repeat. We're going to have to load the thing in our load sound, my sound class. So public string file crash 3 equals car crash 3. And then the audio source. Hide an inspector. Public audio source. Aud crash 3. And something's wrong. Right there. Then in the load sounds, same thing as 2. Let's just change the number. So copy paste. I don't usually like copying and pasting because it wind up being something I forget to change after the copy and paste. But 3 spots, I got them. And now here in the collision, it's either I play the car hit sound or I just say sound dot aud crash 3 dot crash 3 play. Okay. So let's see what happens between the two. One, if I hit head on, it should like turn the car off. If I hit on the side and it's like a scrape, then it should just make the sound, but keep driving. Okay, cool. And I can keep going forever. But I'm going to stop here with my car engine sounds tutorial video and how to make all the different sounds. You can find the source code, the project. I'll put it on my on GitHub, and the link to the GitHub will be put in the description of the comments section. All right. Thanks, everybody. Bye.